Okay, so this one's in our standard, given to us in our standard form. So we can jump right in to find the integrating factor, which will be e to the integral tangent x dx. That's not a integral we're familiar with, so we can go to our integration tables and figure out that that's the antiderivative of the tangent function is e to the natural log of the secant function, secant x dx. And those guys will cancel out because they are inverse functions. So it just leaves you with the secant function. Okay, so that's nice. Let's see what happens. I'm going to multiply everything by that. So multiply both sides of this equation by the secant function. So that gives me secant x times y prime plus y times secant x times tangent x. And if I multiply everything here by secant x, I get secant squared x. And then cosine times the secant, those are reciprocal functions. So secant times cosine is 1. So that's just going to be 9. Okay. Now, well, this, oops, my pen is not cooperating today. My stylus, I should say. This should always be the derivative of a product. And that product should be secant x times y, right? And if I took and that's the derivative. So those two things are the same. What's in yellow is the same. Sorry, I didn't like that little yellow parenthesis, which I keep getting. So secant x times y, that product derivative, right? Same thing. And then over here, I'll just rewrite this, secant squared x plus 9, and then I'll integrate both sides. The integral of the derivative is just that function. So that's secant x times y equals the derivative of secant squared, or the antiderivative of secant squared is your tangent function. The antiderivative of 9 is 9x plus c. Okay, good. Now, where was our initial condition? Y of 0 equals 5. So now we can figure out what c is by using our initial condition. Y of 0 equals 5. So if I plug in 0 for x, 5 times the secant of 0 plus the tangent, the tangent of 0 plus 9 times 0 plus c. That should allow me to solve for c. Okay, so you got to remember what the secant of 0 is. A lot of trig in calculus, right? So I know that what I usually do with those if I'm having trouble is find the cosine of 0 and then take the reciprocal, right? Because the secant is the reciprocal of the cosine. So the secant is 0, cosine of 0 is 1, so is the secant of 0, 5. Tangent of 0, of course, is 0. So that gives me c equals 5. Okay, save myself a little room here. C equals 5. I'm just going to come back here and run that in. C equals 5. Okay, so what's next? Well, we're done, pretty much. We've solved for C. So if we can solve for y, we solve for y, right? If sometimes, like I said, we have to leave this in implicit form if you can't solve for y. But this one's pretty easy to solve for y. We just divide everything by the secant function. Why is my pen doing that today? Y equals tangent divided by secant. If you need to, get to do a little trig identity stuff here. Tangent over secant. What do we do in pre-calc class? We usually did this. A lot of times we change everything to sine and cosine. So the secant dividing by the secant is same thing as multiplying by the cosine. Right? Secant is 1 over cosine, so you divide by 1 over cosine. You multiply by cosine over 1, so tangent over secant is just the sine function. And of course, 1 over secant is the cosine function. And from there, there's not too much we can do. That answer looks good to me. I guess I could factor out a cosine, and I get, what do I get? 9x plus 5.